This is a far cry from the setup that I used when I was doing oil sampling. Recycling hydraulic oil. But I'm going to do a crude approximation because that's close enough to do what I want to do. What I've done is I've captured the oil in this tray. Take this oil soaked rag and put it in the can over here so it's got a closed lid. I like using that little garbage can in the basement down here. If there is a fire that tries to start in there, it's going to smother out from lack of oxygen. And it's a nice steel can that's going to contain the heat and not let it spread. I don't do anything down here as a general rule with open flame. Looking at the oil sample, you can see these gold streaks in it. Kind of a cool effect, huh? Well, gold streaks in it, that's not so good. Gold is usually bronze, and gold streaks means that the bronze wore away. I really don't want to have bronze wearing away. The idea of a bronze bearing is it's softer than the steel shaft that it rides in, so you have the bronze bearing as a sacrificial piece, but ideally you have the two pieces separated by a film of oil so that they never touch. And if they never touch, they don't ablate the bronze off of the bearing. Looks like this thing has run without enough oil in it for a while, because the oil that's in this tray is way too little for the amount that should be in there. My lab equipment. Yep, that's a ragu jar. And this is a coffee filter. That's the top off a half-gallon milk jug. And this is just some paint thinner. Something I'm going to use to thin out this oil so that I can mix it up and get it to go through the filter a little bit easier. If I tried to drain this 90 weight oil through that filter, it would do it, but it would take forever. And I'm not that patient. So my goal is to put the filter down into the funnel and have it capture the metallic particles as I pour them through the filter. I'll capture the resulting mixture in the glass jar so that I can dispose of it, and it'll leave the metallic particles in the paper. Now, when I was doing this as a part of a recycling process for recycling hydraulic oil back in 1981, the idea was to have nothing in the oil left after the recycling process larger than 3 microns. Now, 3 microns is pretty small. I use my saw blade mixing device. You can see the metal particles coming out of the oil. This isn't straight mineral spirits. It's mineral spirits with some other stuff in it to make it safer. It's not as flammable, and it still thins the paint okay, but it doesn't do as well at washing parts. And I bought that whole, I think it's 128 fluid ounces, with the idea that I was going to be using it to wash parts. Doesn't work so good, mostly because it doesn't dissolve oil very well. But it's what I've got, so it's what I'm going to use. And since I'm not trying to get a parts per million off of the test here, I just want to see what the bronze streaks are, what the metallic streaks are in there. Bronze is not good. Steel is even worse. And what I'm seeing in here is a lot of gold. That's bronze. Okay, we have it mixed up enough, I think I can pour it. Now I'm going to pour my sample, such as it is, down through the filter. Kind of a cool look down there, isn't it? Metal flake paint. Not something you want to see in your gearbox, though. And as you can see, my filter paper doesn't capture all the fine stuff because I still got fine stuff down in the bottom of the jar. But it's going to be good enough so that we can see some of the particles. Since I lack a table for the microscope, we're going to improvise again. You can see the tiny little flakes of brass down in there. That's a great big fingerprint. That's looking through a 20 power scope. I don't have a reticle to tell me what micron size those particles are, but I can tell you from experience, having looked at hundreds of samples through a 10 micron scope, that those are really small. That would actually pass through and be called good enough recycled. As far as size, the quantity is a little daunting. As I showed you, in the bottom of the tray, there's quite a bit of material. But hopefully, Skilsaw and its reputation for building robust equipment is going to pull me through on this one. Hopefully they've put enough bronze in those bearings, and the bearings are big enough that I'm seeing wear in there, but not enough to cause it to be unusable. So what I'm going to do is I'm going to set this up and fill it up with oil. According to the little marks on the side of my saw here, it says oil level and operating position. I have the saw set down flat, so this is level. You can see that oil slowly moves to the gearbox. And I think that's pretty close to level. I'm going to give it a minute or two to settle out and make sure I haven't got any bubbles in there. Yep, it's filled up to the mark. Put the cap back in it. Tighten it down snugly. Wipe up my spill. Now we do a test run. Sure, I put the cap back on the oil so I don't have a spill. This is a seriously big saw. Weighs about 14.5 pounds, which is heavy. And this saw blade is by no means the best. Let's give it a shot. considering the condition of the blade, not a bad cut. The cord unplugged. I want to do a little bit of checking. I got a pretty good rattle in that. That tells me I got a fair amount of wear in those gear teeth. But it cuts well. Got some rattle to it. But it's still a functioning saw. That's a monster.